All right, let's look at Pascal's triangle. Pascal's triangle is a really neat way to calculate binomial coefficients, and it's a good way to do it without, if you want to do it by hand. Now, what you do with Pascal's triangle is you start with a 1, and then on each level you put a 1 on both ends, and in the middle you sum the two numbers above to get the entry. So like here we add a 1 on each end and we sum both of those to get 2. To get the next level we put a 1 on each end, we sum 1 plus 2 to get 3, we sum 2 plus 1 to get 3. And so notice there's nice symmetry there. And this continues throughout the thing. Let's add 2 more levels. The next level we put a 1 on each end, and the entries we get would be 1 plus 6 is 7. Then 6 and 15, that would give us 21. 15 plus 20 would give us 35. Then 35, 21, 7. And then one more row. I would get 7 plus 1 is 8. 7 plus 21 is 28. 21 plus 35 is 56. And 35 and 35 is 70. So you can do that, and you can just keep going. And these numbers are all the binomial coefficients. For instance, let's just pick one and play with it. This right here, this 15. What that is, it's on row 6, and it's entry 0, 1, 2, 3, 4. So what this says is 6 choose 4 should be 15. 1, 2, 3, 4, 6, 5, 4, 3. So that's 30 over 2, sure enough, is 15. So Pascal's triangle is just a good way to list out a bunch of these binomial coefficients. All right, so this says use Pascal's triangle to expand 2x plus 5 to the third. So this is asking us to do the whole thing. I'll tell you what though, before we do that, I want to look at one more thing up here. What these are, if you take x plus 1, or better yet, let's just say x plus y to the nth power. This is going to, and the important thing is over here I've just got a 1 for both my coefficients. This is going to give you all the coefficients. Notice if you take it to the 0 power, you're just going to get 1. Well, that's this. If you take it to the first power, you just get x plus y. The coefficients there are 1 and 1. If you take x plus y squared, you get x squared plus twice the product plus the second one. Your coefficients there are 1, 2, 1, which comes straight from this row. And it keeps going. If you wanted to do x to the third, you get x cubed plus 3x squared plus 3x plus 1. Maybe it's worth writing that out before we do a complicated example. So if I wanted to say x plus y to the, let's say to the 6th power, I just come down here to this row. X plus y to the 6th is going to be x to the 6th plus 6x to the 5th plus 15x to the 4th plus 20x to the 3rd plus 15x squared plus 6x plus 1. And that's all there is to it. Now I got 2 examples down here I want to do. 401 and then 402. So use Pascal's triangle to expand 2x plus 5 to the third. All right, so this is going to be the sum. K goes from 0 to 3 of 3 choose K. My 2 things here are 2x to the K and then 5 to the n minus k. So I'm going to pull my coefficients from row 3 up here. So what I'm going to get is 1, 3, 3, 1. Let me actually write the whole thing out. For k equals 0, what I get is I get a coefficient of 1, then I get 2x to the k, which is 0, then 5 to the third. Then when k equals 1, my coefficient is going to be 3. I get 2x to the 1, 5 to the second. When k equals 2, my coefficient is going to be 3 from up here. 2x to the second, 5 to the first. Then my last one, k equals 3, my coefficient's 1. So I get 1 times 2x to the, what's k here? 3. And times 5 to the 0. All right, so it's just a matter of multiplying this stuff out. That first term is just 5 cubed, so that's going to be 125. The next term, let's see, what do we have? We've got 5 squared, so that's 25 times 2 times 3. So that's 50, that's 150. And of course, x just to the first power. The next one is going to be x squared. And what do we have there? You've got 5 times 4 times 3. So 5 times 4 is 20, times 3 is 60. And then the last one, this is 1. 2 to the third is 8. And so that's 8x cubed. And that's our answer. Let's double check it. Come over here. 2x plus 5 to the third. Actually, that's what I've already got. 2x plus 5 to the third. Oh no, that's 2x plus 3 to the third. 2x plus 5 to the third. I will get this right eventually. 2x plus 5 to the third. And let's see, this should be exactly the same as what we had. 8x cubed plus 60x squared plus 150x plus 125, sure enough. All right, last thing, this is the last example. Use Pascal's triangle to find the coefficient of x to the fifth and the expansion of this. All right, so we're interested in, let's see, n is 8, k is 5. So what we've got here is 8 choose 5, and then 3x to the fifth, then negative 5 to the, let's see, 8 minus 5 is 3. So let's see, 8 choose 5, that's 8, 7, 6, 5, 4, over 1, 2, 3, 4, 5. I really should be putting multiplication symbols between those, but I'm being lazy. So I can cancel all that. I can cancel the 2 and the 3 with the 6 as well. So 8 times 7 is 56. This is 3 to the fifth, that's 243. Then 5 to the third is 125. It's negative. And now I need my calculator. 56 times 243 times 125. Oh wow, this is huge. 1701,000. So the coefficient of this is negative 1,701,000. And we're able to do that just quickly with nothing but a hand calculator. All right, So that's probably not something you'll really need to do that often as far as, find some random coefficient. Actually, if you take combinatorics, you might need to do that at some point because this is kind of important. But, if you're just taking calculus or, other classes like that, it's really good to be able to do this kind of problem up here. If you're, cubing or raising something to a fourth power. But anyway, this is a good topic and I wanted to include it in the honor section of this class. So anyway, that will finish this section.